Hello, welcome to my channel. We have been solving these past papers. So right now I have this mathematics paper 5 probability and statistics, and it is May June 2024. So we have already solved a few questions. So I will jump to question number 5 right now. Okay, so this is question number 5. Okay, in a certain area in the Arctic, probability that it snows on any given day is 0.7, independent of all the other days. Find the probability that in a week it is 5 days. Okay, okay. Let me ask you another question. Let's say probability of head, right? You throw a coin, and probability of head is p, right? And what's the probability of tail? It is 1 minus p, of course, right? Okay. Now I ask you, if you throw this coin 5 times, that what's the probability that head will come 3 times, right? Okay, you want to calculate this thing. Okay, so basically, if you throw 5 times, mean 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and so you had 3 heads, so 1 head, 2 head, 3 head, and 2 tails, right? What's the probability of this thing? The probability of head is p, so it is p power 3, right? And probability of tail is 1 minus p, and it is 2 times, so it is 1 minus p power 2. Am I right? Okay, now how many different combinations are possible with 3 heads and 2 tails, right? I mean, this is possible that you have head and then tail, tail, and then 2 heads. One, two, three, four, five, yeah, right? So there are different combinations possible. How many combinations are possible? That is 1, 2, 3, 4, so 5 combination 3, right? So this is the probability of having 3 heads. Does it make sense or no? Okay, now in this question we have the same logic. Okay, you have 7 days, and out of 7 days, what's the probability that at least 5 days have snow? Okay, so this probability, what you want to calculate, it is probability that snow is 5 days, or probability that snow is 6 days, or probability that snow is 7 days, right? Find the probability that in a week it snows on at least 5 days. So 5 days, 6 days, 7 days. Okay, now what's the probability of 5 days, right? Uh, 5 days out of 7. So it is 7 combination 5, right? So many different combinations are possible. Probability of head mean probability of snow or probability of success. It is zero point 0.7. So zero point 0.7 has to be power 5. And no snow is 1 minus zero point 0.7. This is zero point 0.3, right? And no snow for 2 days because 5 days is snow. So out of 7, it is 2 here, right? Plus, what's the probability of 6 days? No. So it is 7 combination 6, right? In fact, this is only 7, right? So of course, probability of 6 is that first day there is no snow, every day is snow, then second day is no snow, third. So you have only 7 such combinations. So 7 combination 6 will give you 7. Okay, into zero point 0.7 power 6 and zero point 0.3 power 1. And lastly, all 7 days has snow, so there's only one combination, right? And that one combination comes from 7 combination 7. If you calculate 7 combination 7, it is 1. And zero point 0.7 power 7 and zero point 0.3 power 0. So it is 1. Okay, let me write it. Nothing down. Nothing. Okay. Okay, so this is the thing which will give you the probability which they're asking us to calculate. And if you calculate all this amount, it will come out to be 0.6471. Okay, you can do this calculation and this will be the answer. Okay, I hope this is clear. Now, second part, part B. In a week in the so this it is called white week. Okay. Now find the probability that in 3 randomly selected weeks, at least one is a white week. So again, if you select three different weeks, right? So probability that at least one is white. So this is white and this is no white, no white, right? What's the probability of this thing? Probability of white is, oh yes, we calculated in the previous part A, so the probability of white is 0.6471 and probability of no white is 0.3529 and it has a power 2 because there are two times. And how many such combinations are possible? Of course, there are only three combinations. White, non, WNN, NWN, NNW, right? Three combination. And that three combinations comes from three combination 1. Okay. Now, what's the probability? So this is the probability that uh, at least one week is white. So this is the probability that white is one. 1 week is white, right? Okay. What's the probability that we have 2 weeks are white? Okay. So of course that is going to be 3 combination 2, 0.6471 have power 2 and 0.3529 has power 1. And probability of white week, all three weeks are white, right? So that probability is going to be 3 combination 3, 0.6471 power 3 and 0.3529 power 0. Okay, so we have to add all of this. So the required probability is probability that W is equal to 1. 1 week is white, or 2 weeks are white, or 3 weeks are white. Okay, so probability of one white week is this thing. So 3 combination 1 is 3 and 0.6471 and 0.3529 power 2. Plus 2 weeks, 3 combination 2 is again 3 and 0.6471 power 2, 0.3529 power 1, and plus last one, 3 combination 3 is 1. So this is 0.6471 power 3, and again this power 0 is 1. So if I calculate all these things, it comes out to be 0.9561. Okay, interesting. I hope you understand all the logic and all the calculation and everything. Okay, part C. In a different area in the Arctic, the probability that a week is white is zero point 0.8. Okay, use a suitable approximation to find the probability that is in 60 randomly selected weeks, fewer than 47 are white week. Okay, let's try to do it exactly, right? So we want to calculate this quantity. Out of 60 weeks, less than 47, so 46 I would say. So 60 combination, sorry, 60 combination 46, right? And zero point 0.8 power out of 60, 46 weeks are white. So 0.8 is a success, it has power 46, right? Okay, yes. And failure mean no snow. It has 60 minus 46 and it's going to be 14. So this thing will give you the probability that the 46 weeks are white. Okay. Now we have to get it fewer than 46 weeks, fewer than 47. So 46 have this probability. What's the probability of 45? That is 60 combination 45, zero point 0.8 power 45 and zero point 0.2 power 15, right? What's the probability that 44 weeks are white? So it is 60 time combination 44, zero point 0.8 power 44 and zero point 0.2 power 16, and so on until your last term is going to be 60 commission 60, which is 1.8 power. It is reducing, becomes 0, so it is nothing, and zero point 0.2 power, uh, zero point 0.2 power is 60. Okay, so you have to calculate this quantity. Okay, of course, it's not fun to calculate this one. This is a huge calculation, right? Okay, but luckily, when n is large, when number of trials are large, the binomial distribution approximates the Gaussian distribution. Remember, all this we are talking about is binomial distribution, right? So basically, we know that for large n, binomial, sorry, binomial becomes Gaussian or normal distribution. Now, binomial distribution is specified by a few parameters n, p, and q. Q or 1 minus p basically, right? Normal distribution is specified by two parameters, which is mean and variance. So how do I find the mean? I'm trying to approximate this binomial distribution by normal distribution. So I need to know the mean and variance. So mean is basically n times p. Okay, and variance, which is sigma, it is square root n p and q, which is 1 minus p basically. Okay, so this will calculate these two parameters. Okay, so I'm trying to approximate this binomial distribution by normal distribution, and for normal distribution the mean is NP, N is 60, and P is zero point 0.8. P is the probability of success, so it is zero point 0.8. So this will become 48. Okay. Similarly, the variance, I told you this is NP into 1 minus P. So N is 60, P is zero point 0.8, and Q or 1 minus P is 1.2, right? And this quantity, this number comes out to be 3.098. Okay, so now I want to calculate the probability that x, let me call it x, the what do you want to calculate? Yes, okay, that x is less than 47, right? Basically, this is what I'm trying to calculate, probability that x is less than 47. And x is the number of weeks which are white. Okay, so I want to calculate this thing. Okay, now I will approximate it with a normal distribution with this parameter, right? So this is same as the probability of uh, okay, okay. Uh, the thing is, since I'm going from binomial to normal distribution, now binomial was discrete and normal is continuous. So I have to calculate the probability that less than 47 are white. So since it is from discrete to analog to continuous, I will approximate my x by 46.5. So probability that x is less than 46.5. Okay. Um, I want to see the probability that less than 47, right? So in this case, I have to stick with discrete values, right? But since I'm going to continue, so that's why I'm approximating it by x less than 46.5. Okay. Now when x is 46.5, what is my z? Okay, so remember z is x minus the mean value divided by the variance. So x is 46.5 minus mean value is 48 and divided by the variance is 3.098. Okay, and this quantity comes out to be minus 0.4841. Okay, so this probability is equal to the probability that Z. Now, what is Z? Z is a standard normally distributed random variable. That Z is less than minus 0.4841. Okay, now remember, we know that normal distribution is something like this, right? It has mean of 0 and variance of 1. So less than this number, so this number is something somewhere over here, minus 0.4841. So we are interested in this area, right? Probability that Z is less than this quantity is this area. Okay, you can see that since it is symmetric, this probability is same as probability that Z is more than 0.4841, right? So basically I'm saying that this area is same as this area 0.4841. So this area. Right? Of course, these two areas are same because this is symmetrical. And this area is my Q function, remember? So this is equal to the value of Q function at 0.4841. Remember, I hope I'm not confusing you. There are many things over here. Okay, now how can I find from the Q function Q table, how can I find this value? Let me show you, but I need to switch it to the screen I'm sharing with you. So give me a second. Oh, yes, share. And now I want to share with you this thing. Okay. Okay, I hope you can see it now. Okay, so I'm article 0.4841. So zero point 0.4 is this, and 0.48 is this value. Oh my God. Yeah, sorry. 0.48 this value. Okay, and since my number is 0.4841, this table is giving me the approximation up to two decimal places. So, but you can see 48 is this, 49 is this, so it is even less than this one. So if you feel comfortable, I should reduce it a little bit from this value and in between these two values basically. Okay, so I will use 0.31 and 5, let's say use. Okay, so 6, I'm just reducing it just to make a better approximation. Okay, let me go back. Uh, yes, share. Now I want to go. Oh my goodness, where is this? Okay, sorry. Okay. Okay, okay, yes. Okay, so I'm back now. Okay, now this Q function, what did we find? 0.315. Okay, so this is the approximate probability, but why is it approximate? Because I am converting this discrete into continuous value. Okay, I hope you understand all this question and all the logic behind every step. If you ever have any question, you can always ask me in the comment section. And if you find these videos helpful, then please subscribe my channel. Thank you very much for watching. See you in the next video.